Bonjour.
Good morning. When I was a little girl, my parents used to tell me, Fatoumata, you're always looking up to the stars, but you're really someone who's realistic too and very pragmatic. Why do I always look at the stars? Because I am, in my professional life, working on space issues, but I'm also very pragmatic, and I'll tell you why. But I have a question for you. Who has a cell phone? Who has a cell phone? Well, raise your hand. And who brushes his teeth every morning? That's the same kind of question because it's something we all have now. Have you used an app to come here, internet, GPS? Have you used any kind of app? Well, if you raise your hand, that means that you use space technology. Space technology, what is it? Well, it's satellites. As you know, those huge items which rotate around the planet and which give us the possibility of having access to specific services like the apps I've just told you about. Now, let's go back to the 60s when we had the Cold War, just before we started going to space. The Cold War was an indirect conflict between the United States and the ex-Russian Republic. But it was a scientific, cultural, and political conflict, as we know, or war. And we know that we have a huge space above our heads. And the Russians won the first battle because they sent a satellite which gravitated around the Earth, Sputnik 1, in 1957, and the Americans won the other battle a few years later with another mission, which was the Apollo mission. They sent cosmonauts on the moon. So we have more satellites now gravitating around the Earth, and we know that they're very sophisticated. But a satellite has a life cycle which is 10 to 15 years. And once the life cycle is over, what happens? Well, he just stays in space, even though the mission is over. And these satellites are there, they stay in the space. But we also have fragments of rockets, and these rockets will dissolve throughout time in the atmosphere. But they stay in the atmosphere. That means that we have pieces of rockets, but also satellites, kinds of debris which stay in the stratosphere, in the atmosphere. But we also have other little waste, like, for instance, paint, debris, and so on. And there are several thousands of millions of these wastes that we call spatial debris or waste. Now, among all this waste that we have in space and which gravitates on our planet, we have very small little items or objects, a few centimeters. Well, we can maybe say that this is not too serious, but if you only have 1 millimeter debris or waste, that has an average speed of 10 kilometers. That means that a small ball that you would use when you have this game with the pétanque, the French pétanque, that means that you have a risk in space, but also on Earth, because it can be a collision taking place with another satellite, which is still on the orbit, and can destroy the satellite which is servicing, and we can't avoid this kind of collision. On the ground, it can have a dramatic repercussion because you have all these debris or waste falling on Earth, and we know that we have a gas layer which covers the whole planet. And if you have an object which goes through the atmosphere, then it will burn. But if the object is bulky, then it will not be completely consumed and can have an impact on a location where you have people. I am finishing my PhD at the Observatory of Paris and also at the Pierre and Marie Curie lab. I'm working on the collisions which can be provoked by these debris and these wastes, and also the clouds that will form due to this. I'm also working on the techniques we could use as to clean up space, because we all know that today we can't preserve our environment if we don't preserve space. And according to NASA, in 10 years from now, we won't be able to send any other kind of satellite in space because there could be a collision with one of these debris or remnants of former satellites. We have an assumption, And we know that today we have another possibility, which is the balloon. If you have a satellite, which is no longer active, you can equip this with a kit, and you have a balloon which will be inflated. And once it's inflated, you will deviate or reverse the trajectory of the satellite, because we know that the debris fall on Earth and in the oceans. I'm working on specific methods so as to clean space of small debris or remnants. This is stardust. It's a stardust mission. That means stardust. And the mission is to see what is the cosmic dust we have in space. This mission has been very successful. We've been working on these dust throughout space at thousands of kilometers, and we have been able to screen, or to have a kind of screening process implemented in space so as to capture all these small remnants or debris we have in space. Now, it's very unusual to speak of the space environment, but I think that if we want to preserve environment, it's not only on Earth, it's also space environment. It's everywhere where we have men, because we have men also going to space, and we have remnants and debris and waste. And therefore, as an astronomist, I have wonderful images like the one we can see here. This is our planet. And when we look at this image, well, then we feel very compelled to see what's going on Earth. Maybe can we find solutions we already have at hand and that we could implement for space cleaning or space preservation. And a few years ago, I was aware of the fact that agriculture is consuming up to 60% of the overall water resources we have, and half of the water is being wasted because of bad practices. And this is why I was compelled to think that as an astronomist, I could also offer a few options to farmers. And this is why I started designing solar sensors that you place, for instance, in a field, and that will tell you what is the water requirements of the field, and which will be connected to an irrigation system so as to use the appropriate amount of water required in the field. In Mali, we are now driving an experimental project and with women, because I'm sure that we will be able to solve many of the problems we have today for the environment with women. And even though I am only one individual working on this project, I would like to quote one of the sentences or verse of the Belgian poet, who is a woman. If you want to change the world, well, just don't stare at the world. You also have to be part of the changes. And whatever thing you do, it doesn't matter, after all. What is important is to do something. And maybe if we pool all our efforts, if we can do this on Earth and on space, well, then we'll succeed. Thank you very much.
Juste un mot?
Just one word.
Elle n'a pas peur de l'espace, mais elle est intimidée par une question.
Fatou is not frightened of space, but she's frightened of a question. There are many school pupils today, but only 10% of astronomers are women. What would you like to say to girls who hesitate to become astronomers? I say you should try. Don't think about success or failure. Don't set yourself limits, and don't listen to the limits that the others are trying to impose on you. I'm an astronomer today because I was naive. I really believed that if I tried to do something, I would do that something. So if you have a passion, don't think about the problems, the difficulties. Your passion will give you enough strength to push away the obstacles. So girls, believe in yourself. Be self-confident. Why are women always questioning themselves and listening to criticism? I remember what Confucius used to say in China. find a job you like, and you will never have to work throughout your life. And this is what I wish everybody.